Right, this lesson is not actually in your notes. I created chapter 9.3.5. If you want to write somewhere, just get a paper and then maybe you can find somewhere to fit in your notes. Today, we're going through chapter 9.3.5, which essentially is a shortcut for chain rule. Now, you have learned last lesson how to work out chain rule, haven't you? Okay, so using chain rule. So to work out chain rule, we can let u to be the inside layer and then make y equals function of u, differentiate on both sides, and then multiply them. But this is way too long. When we apply chain rule in real life, when you become more proficient, and this what you usually use in your exam is the shortcut. Why do we need a shortcut? Well, shortcut is good for everything, right? Just, when people say there's no shortcut to life, I'm pretty sure what they mean is they couldn't find that shortcut. If there's a shortcut to anything you want, I'm pretty sure every single person would take it, or most people would take it. Okay, imagine there is no backfire, if there's no consequence using shortcut, why not? Okay, if there's a shortcut for you to become a millionaire or billionaire, would you take it? You probably would. However, I'm not asking you to rob the bank or anything, but if I tell you, okay, straight away, there's a shortcut to do that. It's not something bad. It's not, perfectly, there's no consequence, which is rare. And that's why not everyone's a millionaire. By the way, do not take a shortcut to do anything to achieve your goal in life, because it is true, there's no shortcut to achieving your final goal. But that's a shortcut for chain rule. After so many waffling, there's no shortcut to chain rule. Actually, there's a shortcut to waffle. Anyway, shortcut to chain rule. What's the shortcut to chain rule? That's what I want to go through with you today. And I want you to learn this by the end of this little video. The shortcut for the chain rule, okay, is, so let me copy this. So the shortcut for the chain rule is, so dy by dx, right, equals to the derivative of the outside layer, so outside layer, outer layer, outside layer, whatever you want to call it, okay, outside layer, times the derivative of the inside. If there are more than one layer, you just keep multiplying more and more. So essentially, you differentiate from the outside to the inside. So you differentiate from the outside to the inside, like an onion. We open layers and layers from the outside to the inside, one by one, bit by bit. The more layers are there, the more tears you'll be bursting, you'll be crying in your eyes. Right, so we'll see how we can apply this, okay, into our previous practice question. So I'll show you, okay. Let me show you with the reverse example we did in here, so maybe you can apply yourself in the practice question. Okay, these lot go away. So let's use the shortcut. So the shortcut is, we can first differentiate outside to inside. So my first step is sort of my second last step. So the outside function is to the power 5. If you have a differential power 5, you multiply the power and then power goes down by 1. So differential outside. So 5 bracket 3x to the power 4 plus x to the power 4. Right, so differential outside, differential power 5, you multiply by the power goes down by 1. Okay, times differentiate inside, so 12x cubed plus 1 put a bracket, and boom, that's your final answer. Okay, it's a lot quicker. Okay, I know you'll be hating me, you'll be swearing, you'll be cursing me to the end of my life. Why did I not teach you last lesson? The reason being is you need to learn the proper way before you do a shortcut. For academic reason, for whatever reason, some harder question is hard to apply the shortcut, then you need to know how to use without the shortcut. Okay, so don't blame me. It's just for your own good. Like what all moms say, drink water is good for you, even though water is tasteless and is disgusting. But anyway, right, so that's the shortcut. Okay, so differentiate outside to the inside. That's the outside. Okay, so that's the outside times the inside derivative of inside. Don't get it? Maybe a few more. Okay. Practice. Okay, so let's try this one. So dy by dx. Differentiate outside power 3. So 3 bracket x squared plus 1 to the power 2. Step by step. When I differentiate outside, the inside do not change because I'm just differentiating power 3. I'm just focusing on the 3. Then next, I can focus on inside now. X squared plus 1, 2x. That gives us 6x bracket x squared plus 1 squared. Finish. Next one more, dy by dx. First of all, differentiate 3 outside. Again, 3 bracket ln x squared times differentiate inside. Differentiate ln x, 1 over x. So my final answer, 3 over x ln x squared. Next one, what about e? Well, e, the differential power of e, you differentiate the power. Okay, so just differentiate the power. Differentiate power, now this is slightly an outlier, a special case. Differentiate power of e, you differentiate the power and just multiply the whole thing by e again. So differential power x squared plus x is 2x plus 1. And then differentiate, and then just put the e back in there. Right? Make as many little notes as you want to. This will come in handy. To differentiate powers of e, I'll give you a small example in here. Okay, let's say y equals e to the power of x squared. How to differentiate that? Or actually, I'll give you something a bit more harder. X squared, actually x squared. Then dy by dx. What's the derivative of the power? X squared, 2x. And then just put the e back in. Okay, right? So differentiate the power and then multiply e. Right. Let's see if you are able to apply a shortcut into here and here. So pause the video, have a go at the question, use the shortcut. When you're ready for the answer, press play. Right. So shortcut. Differential power of 2 is 2 bracket 2 to the power of x plus 1 to the power of 1. Differential inside 2 to the power of x is a to the power of x and then a. Without doing any simplification, which is not our aim today, that's the answer. Right, next one. What about the last one? dy by dx. Differentiate outside. What's the outside? The outside is ln. So let's differentiate ln. Anything ln derivative is 1 over. Right. Times differentiate sine x, cos x. That's cos x over sine x, which becomes cot x. That's not the point. So I'll explain again. Differentiate ln is 1 over. Differentiating ln x, let's say d by dx of ln x or ln 7x, we know the answer is 1 over x. So it's 1 over whatever's inside. So whatever. Oh, yes. Okay, let's come back to this one, actually. Okay, so that's why 1 over sine x. Let's go back to chapter 9.2. I did tell you why I was going to explain why that one is, why both of them are equal 7x. Why that one is 1 over x. Okay, let me explain why using chain rule. Differentiate ln x is 1 over x. Okay, why is differentiate ln kx is still 1 over x? Now, because of this, using chain rule. So long way round, okay, long way. U equals to, let me get in color. U equals to kx. Okay, so u equals kx and y equals ln u. Du by dx is k. Dy by du is 1 over u. So dy by dx equals to k times 1 over u. But what was u? U is kx. So k times 1 over kx. K and k cancel out, so it's 1 over x. Right? Shortcut. Well, why? Shortcut. Dy by dx. Right? Shortcut. Differentiating outside, differentiate ln is 1 over whatever's inside brackets. 1 over kx. Differentiate inside, differentiate kx, differentiating 2x is 2. So differentiate kx is k. K and k cancel out, so it's 1 over x. So whether you want to remember the result or not, it's not the end of the world. Okay, if you remember it, remember it. But what you have to, one thing that you have to remember is 1 over x. That ln x. When you differentiate ln is 1 over whatever's after the ln. Okay. Right, if you want to do more of the practice question, of course, you want to try them, then you can go back to chapter 9.2, the homework, and try it with the shortcut. Okay, so you can try any question that you've done before using chain rule in the chapter 9b, I think exercise 9c, 9.3, sorry, 9.3, anything with 9.3, 9c, you can have a go using shortcut. Okay, if you don't get it, come and ask me. But you need to master the shortcut, all right? And there's a secret recipe for you. It's a shortcut of a chain rule. You need to master it, right? Maybe one more. If you don't want to listen to me waffling, you can stop it there. But I'll just do one more if you want to listen. How do you use the shortcut for this one? Well, to differentiate ln to dy by dx, differentiate ln is 1 over what? Whatever's inside bracket, x squared plus 3x plus 5. Next, differentiate inside. Differentiate inside, x squared bracket 2x. Differentiate 3x is 3. Boom, 2x plus 3 over x squared plus 3x plus 5. Now, if you were wondering why is it 2 marks so many steps before, now you know. 2 marks, 2 steps. Right? So, and that's a shortcut. That's a shortcut for chain rule, which you need to master it.